Hassler here. All right, so I'm going to go over some ideas for the multiple choice set number 8. This is on a review of the derivative for inverse functions and on area related to Riemann sums or trapezoidal sums. Okay, so I'm going to take a look at the derivative of an inverse function first. Now, this is the type of question that should only pop up like once, maybe twice if you're unlucky. So it's just one of those rules that you have to know that's buried somewhere in the back of your head. But here's the rule. It says if g of x is the inverse of f of x, then g prime of x, the derivative of the inverse, right? If g is the inverse, then g prime, the derivative of the inverse, is equal to 1 divided by f prime of g of x. Okay, and that's just the rule that you have to remember, and you have to remember the relationship between these functions, right? And so I know that if f of x has the ordered pair a comma b, then g of x, my inverse function, has the ordered pair b comma a, right? One of the properties of inverse functions is that their ordered pairs are flipped, okay? And the other thing that I want to share with you is the notation. So sometimes they will define g of x as the inverse of f. So if f is the regular function, we'll say. Sometimes they'll say that g of x is the inverse, and sometimes they'll say that this notation, this f to the negative 1 of x, that's also inverse notation. That would be the inverse function. And so they could define it either way, okay, either using f inverse, or they could say g. And so if they say f inverse, by the way, I just want to go back and put this in terms of that. This would be equivalent to saying, hey, the derivative of f inverse, or the inverse of f, would be 1 over f prime of f inverse of x. Okay, so that's the other way that we could think about that. Okay, and so your job is to use that formula and this idea right here, that you switch the ordered pairs in order to evaluate the derivatives of inverse functions. All right, let's review Riemann sums / trapezoidal sums. All right, so for a Riemann sum, what you are technically evaluating is area of a rectangle for the Riemann sums. And that area is equal to, base times height. But for our purposes, it's equal to the output at a particular x times delta x. All right. And so I only need, we talked about delta x and how to calculate delta x. I only need to calculate delta x, which, by the way, is the length of the interval divided by the number of subintervals. And I only need to do this if you have equal subintervals. Okay. If I have equal subintervals, then I need to calculate what the delta x will be. If I don't have equal subintervals, if the subintervals are indicated by the table, then the delta x is equal to the change in x, okay, for each interval. I'm going to say for each subinterval. And that happens to us. So it'll say, given the subintervals indicated in the table. Well, then I got to go through and every calculation here, I would have a different delta x. Okay. Remember that anytime we're talking about area, whether it's area of a rectangle or whether it's area of a trapezoid, that area is equal to a definite integral on some interval from a to b of my function. Okay, and so all of your Riemann sums are equal to the left Riemann sum or the right Riemann sum or the midpoint Riemann sum or your trapezoidal sum. Okay, all of those are going to be equal to a definite integral, or the definite integral that they give you represents your area calculation. All right, let's review how to find the area of a trapezoid then. So area of a trapezoid is equal to 1/2 the sum of the bases times the height. Let me draw you a picture. The trapezoids that you're going to see are most likely going to look like this, or they are most likely going to look like this. Okay, and so I'm going to label my bases are going to be the height of your function, right? So f of, we'll call this a and we'll call this x, f of a and f of x. Those are your bases. Your height is this right here, and that's your delta x, okay? And so, again, your delta x could be of equal subintervals, and you do that delta x equals b minus a divided by n, the number of subintervals, or delta x could be indicated by what is in the table. Okay, so your job is to complete this set to the best of your ability. You only have 7 questions. Check the answer key and let me know what you have questions on.